Hello everyone, welcome to Nrcm. I'm going to explain operating system subject and of unit 3, and today's topics are resource allocation graph. Coming to the resource allocation graph. What is a resource allocation graph? Actually, resource allocation graph, it is a deadlock of avoidance technique. So with the help of this resource allocation graph, we can identify whether any of the deadlocks are present or present or no. So before going to the resource allocation graph, like we know that as normal graph refers to, in normal graph, V refers to the set of vertices and E refers to the set of edges. So, and here as shown in the slide, like P, what is the meaning of P as shown in the slide? So here P, these are nothing but these are the processes. These are the P's. These are the processes. So these are the processes, and next R refers to the resources in the system. And here we are having in resource allocation graph, we are having two types, or we need to remember the two things. First one is request edge and second one is assignment edge. So request edge refers if any of the process is requesting the resource. If the process is requesting for the resource, then the direction will be it will be, the direction will be in this way. I think you can see this. And assignment edge is if any of the resource is assigned to the any of the process, so then the direction will be in like this. Means here it shows, like here it shows the process is requesting the resource. Process is requesting for resource, and it shows resource is allocated for process. Okay, I hope you all understood. And next we are going further. We'll see how the resource allocation graph will be there. So first, so we have discussed in the previous slide, like process can request the resource. They'll be having request edge as well as assignment edge. Okay, if request edge means process will be requesting for the resource, and assignment edge means like um, in assignment edge, like request will be allocated to the process. Okay, this we know. But in coming to the, like in algorithm, how do you identify, like this is the process and this is the resource? So by seeing these examples, like we'll understand. So if the process will be mentioned in circle, so if you find the circle in the resource allocation graph, then we should think that, so this is the process. And if you find the square box in the resource allocation graph, then you should think it is the resource. And I think you can see here, like within the square, there are different like instances within this square. Okay, so these are nothing but like this informs us, like there are four resources present within this resource. So within this resource there are four resources. The resources might be like it might be like memory, CPU, or any other input output devices. Okay, and next is like, so if by saying this, by saying this, you can understand like pi request instance of RG. So pi request instance of RG, if any of the process is requesting the resource, then the arrow will be like this, as I discussed in the previous slide. Okay, here if the arrow is like this, so what for, to wherever the arrow is pointing, so if the arrow is pointing to the resource, then process is requesting the resource. And if the arrow is pointing towards the process, then resource is provided by the process. I hope you all understood this. Okay, next, going to the example of resource allocation graph. So here we can see the example of resource allocation graph. So as I discussed in the previous slide, like this is P1, so it is in circular shape. It is in circular shape, so this is the process. Okay, and whichever it is that it is in rectangular shape, now this is a resource. Okay, so in this way we can identify like which is process and which is the resource. By seeing the directions, we can identify whether the process is requesting it, whether it is request edge or it is assignment edge. So if you keenly observe here from the resource one, how many resources are there? This is R1 and this is, there are two resources and there are two processes. Okay, So here what happens, and I think you can see here there is only one single dot within the resource part. So what is the meaning of this? The meaning is like there is only one resource with present in this resource, only one result, that only one resource is present in this resource, single resource allocation you can tell. Okay, or single instance is present within the resource. Okay, and this line indicates like this line, see so the direction is towards process. So we can say like resource is assigned to process, and the direction is towards the, and here the direction is towards the resource. So you can say like process is requesting for the resource. Okay, by saying this overall diagraph, so what did you understand by saying this resource allocation graph? What did you understand? So whether there is a deadlock or no? Yes, there is a deadlock, because whenever the cycle forms, obviously the deadlock will occur. So because why the deadlock is like, see here, so process is already holding resource 1, and it is holding resource 1 and it is waiting for the resource 2, means this is not released here. And next is, and here coming to the process P2 is also holding the resource R2, and it is already assigned, R2 is assigned to the P2, and it is waiting for R1. So here what P1 will do, so P1 won't release this R1 until it gets R2. And coming to P2, what it will do, process 2, it won't release the R2 until it gets R1. So here there is a deadlock. I hope you all understood. Next, we are moving to the next slide. So, and here there is a resource allocation graph without a deadlock. So how to identify whether like if it is very clumsy to y'all, like in the as shown in the previous slide. So it is, if it is very big like allocation graph means, so remembering things will become very difficult. So in that cases then we can draw the table like this, and we can identify whether the deadlock is present or not. So here these are the processes, how many process, I'm just explaining the table, how many processes are there. So here process P1, P2 and P3, three processes are there. So there are three processes. And next here one is allocation block, and second one is request block. So allocation block is like how many resources are allocated to different process. As you can see for P1, so for P1 R1 is allocated and R2 is not allocated. See here P1 is here, so for P1 R1 is allocated, and it is waiting for R2. Okay, next in the same way for P2, like R2 is allocated and it is waiting for R1. And next for P3, which resource is allocated, R2 is allocated. And here if you see in R2 there are two instances within the R2. Okay, and this is of allocation part. And now we'll be seeing the request part. So what all the processes are requesting, which processes are requesting for which resources. Okay, see coming to the P1, so it is requesting for R2, and P2 is requesting for R1, and P3 is not requesting for either of the resources. Okay, so by seeing this you can identify whether there is a deadlock or no. See, suppose first of all coming to the P1 is already having allocation, it is already having R1 and it is requesting for R2. Here as R2 is not there, so it will be requesting for R2. So here, and R2 is held by any other process? Yes, it is held by this like P2. So first what P2 will do? So first P2 will be executed. So P2 is having R1 and it is requesting for R2. Okay, and it is requesting for R2. What happens here? So, and the resource needed is like it requires resource 1. So again, so it will come to the P3 now. So here P3 is having R2 and it is not requesting for any of the resource. So first P3 will be executed. So first P3 will be executed. So after execution, what will be the resources like this R2 will be released. Yes or no? So here R2 will be released, and here comes for R2, at R2 also 1 will be there. Next coming to the P2. So P2 is requesting for R1 and it is requesting for R2 also. So before that there is P1. So P1 is having R1 and it is requesting for R2. So R2 is already available. So next second this P2 will be, process 2 will be executed, and means the resources will be allocated to the process P1, and later this for P2 the process will be allocated. So here all the resources will be equally managed, equally managed one after the another. So here there is no deadlock. And next, coming to the basic facts, like how can you identify like whether there is a deadlock or no? See, if any of the graph, that resource allocation graph, contains no cycles, so if there are no cycles means there will not be any of the deadlock, any kind of deadlock. So if graph contains a cycle, it's not like that if graph contains a cycle every time it is, I mean, there is a deadlock. So I mean, it depends. Like, see, if only one instance per resource type, then it will have the deadlock. Means only one instance is there and many resources are opting for that or requesting, then obviously the deadlock will occur. And if several instances per resource, possibility of deadlock. So possibility means it might be or the deadlock might not occur if several instances are there. Okay. And next, in next slides, I mean, I hope you all understood this, and thank you. Well, coming up with the next videos.